Good morning, geometry students. Today we are doing trigonometric ratios, which are super cool and I love them just because they're really useful. My husband does satellites, like telemetry and having to know where the satellite is going to be at any given time. And part of his training to do that, he had to use trigonometric ratios. So they're super cool, and right triangles just lend themselves to so many applications. Our learning target for today is that we will define and calculate sine, cosine, and tangent ratios, which you need calculators for. You need the scientific calculators, and the big graphing calculators we have will work for this. Then we're going to use Trigonometric ratios to solve problems. Our vocabulary is that we have cosine, coseno, we have sine, seno, we have tangent, tangente, and we have trigonometric ratios, razones trigonométricas. Here's a concept. We have the trigonometric ratios or functions that relate the side lengths of right triangles to its acute angles, right? Because in a right triangle, the other two angles are acute. The sine, and this is just a definition, and you'll have to memorize it, but I have a trick for you to help you memorize it. It looks like a lot. So we have sine, which is the length of the opposite leg over the hypotenuse. Okay, so that's for sine. And the way I remember it is I say so, like so what? So it's sine, and then it's O over H, like this. So, and the O is for opposite, and the H is for hypotenuse. Okay, and the S is for sine. Then when we're trying to figure out cosine, it is the length of the adjacent leg, which is right here, to angle A, over the hypotenuse. So we will have, for this one, the way I remember it is ka. Ka, like a crow says ka. Ka. And that's for adjacent, the A, and H is for hypotenuse. All right, we now have so, ka. And for tangent, it's toa. Like my toa is on fire. I don't know if you're stepping on coals. All right, remember this. So, ka, toa. Kind of like the songs I was singing to you yesterday. These little mnemonics help you remember things. All right, I used blue for the adjacent, and I used green for the opposite side. So in toa, we have O for opposite and A for adjacent. And then they showed you how to do that with like the BC over AB right here, and the AC over AB, and the BC over AC, but we'll just get to application and not worry about that right now. All right, we're going to practice. SOHCAHTOA. What are the sine, cosine, and tangent ratios? All right, of angle H. So I'm just going to highlight angle H because that's what we're looking at. And you need to know what adjacent and opposite mean. So we're going to start with sine, and sine is so in SOHCAHTOA. So the sine of H is going to be equal to the opposite side of H. The opposite is 12, and the hypotenuse is 15. Okay? So opposite is what side it points to the angle, or the angle points to the side. Then we want to do ka for cosine. So the cosine of h is equal to the adjacent side. Well, the adjacent side is 9 because it's next to the h. It's touching it. And the hypotenuse is the longest side. So it's going to be 9 over 15. We should probably reduce these. So this can be divided by 3, so it would be 4 over 5. And this can be divided by 3, so it would be 3 over 5 also. Then we want to do the tangent, TOA. So the tangent of h is going to be the opposite side, which was 12, and the adjacent side, which is 9. These are also divisible by 3, so that's going to be 4/3. And those are what we call the trigonometric ratios. And they work for right triangles. Then they're asking us to do the same thing we just did, but for f. But I think you can do that in your small groups, right? So I just showed you how to do it. Follow those exact same steps, but instead use angle F as your angle for your opposite and adjacent angles. And then you might see a pattern, which we'll talk about when we come back to the video, or before we play the video. We're going to talk about any patterns that you notice between angle H and angle F. What do you notice between their sine, cosine, and tangent, your trigonometric ratios? And then we also have this next one where they tell us that A is equal to 5, B is equal to 12, C is equal to 13. What are the sine of B, angle B? What's the cosine of angle B? And what's the tangent of B? And you can make your trigonometric ratios using SOHCAHTOA. So SOHCAHTOA. All right, and I'm going to take volunteers to tell me what you think these are. As you work more with sine, cosine, and tangent, you start to see some patterns and relationships. So we're just going to talk a little bit about some of those patterns in this section. When we have a 30, 45, and 60 in our angles, those come from special right triangles. So remember, we have the 30, 60, 90 degree triangle, where again we have S, 30, 60, 90, 1√3, and 2. See, I have to sing the song to be able to know what they are. And then we have a 45, 45, triangle. And in that, we have our two sides. Side, side, side square root 2. Side, side, side root 2. Okay. So they're saying, what's the sine and tangent ratios? Well, it really doesn't matter because the S is going to end up canceling in these. So watch this. We have the sine of 30 degrees. Well, the sine of 30 is going to be so what? Opposite would be S, and the hypotenuse would be 2S. The S's end up canceling out, so the sine of 30 would be 1/2. And that's going to always be true no matter what S is, because the S cancels. And then let's do cosine of 30. Ka. Adjacent, which is s root 3, and hypotenuse is 2s. So that's, the s's cancel, so it's always going to be root 3 over 2. That's for the cosine. And then the tangent is oa, toa. The tangent of 30 is opposite of 30 is s, adjacent to 30 is s root 3. Ooh, we don't like the root 3 in the bottom, but the s's cancel. So we would have 1 root 3, but then we would rationalize it. So that's going to be root 3 over 3. And that's just for the 30 degrees. But I'm going to do the 60 next, and we're going to see a pattern. For now, I'm going to just move this guy over because I don't have space. We'll get back to him later because the 45 will be the last one that we do. So we have sine of 60, cosine of 60, and tangent of 60. And we're going to do so, ka, toa, SOHCAHTOA. And there's a story about that. Like if you burn your foot, then you have to go SOHCAHTOA. Because it's hot, right? Soak it in water. SOHCAHTOA. Okay. Cheesy jokes aside, the sine is 60, so I'm looking at this angle 60. The opposite side is s root 3, and the hypotenuse is 2s. So that's going to be root 3 over 2, which you saw as the cosine of 30. So now the cosine of 30 is root 3 over 2, and the sine of 60 is root 3 over 2. So there's already a pattern. The cosine of 60 is the adjacent side. So the adjacent side would be s. The hypotenuse is 2s, so we get 1/2 because the s's cancel. And for tangent, we have the opposite, which is s root 3, and the adjacent, which is s, so it just equals root 3, which is the inverse of 1 over root 3. So you can see like this 1/2, the cosine of 60, is the same as the sine of 30. And 30 and 60 add up to 90. And so that's a property of sine and cosine, is that they are the same, like they're equivalent if the degrees add up to 90. Then we have sine of 60, which is root 3 over 2, is the same as the cosine of 30, which is root 3 over 2. But then with tangent, we actually have inverses. So before we rationalized it, you can see that that's the inverse of the root 3. 1 over root 3 and root 3 for tangent of 30 and tangent of 60. Now we need to do the sine of 45. And so I'll draw, remember I said I would save that triangle for later. So this is a 45, 45, 90 triangle. Oops. And we want to find the sine of that. So remember that this is s root 2. So looking at 45, the SOHCAHTOA, the sine, is equal to the opposite, which is s, over the hypotenuse, which is s root 2. We have to rationalize that. The s's cancel, but then we'll multiply by root 2 over root 2. I'm running out of space. So I just want to keep this separate over here. No. Keep that separate. When I rationalize root 2 over root 2, then, and the s's cancel, it ends up equaling root 2 over 2. And that is the sine of 45. Let me fit that in here, sine of 45. Then the cosine of 45 degrees is equal to the adjacent, which is the side again, over the hypotenuse. So it's also going to equal root 2 over 2. So both the cosine of 45 and the sine of 45 are the same, root 2 over 2, always, because the s's cancel. No matter how big your triangle is, the cosine and the sine will always be square root of 2 over 2 for a 45 degree. Then we have the tangent, and the tangent of 45 degrees is the opposite over the adjacent. I forgot to write that with cosine. It was the adjacent over the hypotenuse. The opposite is s, and the adjacent is s, and s over s is just 1. So the tangent of 45 degrees is always equal to 1. And those are special triangles. For 3b, how can you write an equivalent expression for the cosine of 70 degrees using sine? Well, like I told you before, the cosine and the sine are like opposites. So the cosine of 70 is also the sine of 20, because 70 plus 20 degrees is equal to 90 degrees. And an equivalent expression for sine of 34 would be the cosine of, let me think, 90 minus 34 is 56, because 34 plus 56 equals 90. Let's apply this trigonometry. A plane takes off and climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles away from the runway, or does the plane need to increase its angle of ascent? And they're telling us to draw a right triangle to represent the situation, which if they don't give you a picture, you should always do that. So we're trying to figure out what x is, and x is opposite of the angle, and 12.5 miles is adjacent to the angle. And if you think of our trigonometric ratios, so ca, toa, you want to use the one that has the opposite and adjacent. So which one will you use? We'll use sine, cosine, or tangent. That's right, we'll use tangent because that's opposite over adjacent. All right, well, the problem is that we don't know what the opposite side is, but we do know the angle. So we can write the tangent of 12 degrees is equal to the opposite, which is x, over the adjacent, which is 12.5 miles. And I'm putting the units because they gave us feet for the mountain, and we'll need to convert our miles to feet, which I think is 5,280, but I'll have to double check. All right, now to figure out x, we want to multiply by 12.5 on both sides. So that'll give us 12.5 multiplied by tangent of 12 degrees. And I think that even your phone calculators will do this, but you should know how to use the big calculators as well. So let me grab my calculator. And I'm using my phone calculator because I'm at home and I don't have the big calculators. but I'm putting in my calculator, turning it sideways, 12.5, and then tangent. Oh, that does not work. So you have to do this backwards in your calculator. You have to put 12 tangent and then times 12.5. And that gives me an x of 2.65. I'm just going to round it to 7 because it keeps going on. So that's what I get when I put this in the calculator. This piece gives me that. Okay. And in the nice calculators that we have in the classroom, you can just put 12.5 tangent 12 and it'll work. But in the phone calculator, you have to put 12 as the degrees, then push tangent, and then times 12.5. So it's a little bit more steps. Now I want to change that that's in miles, so I want to change it to feet. So to change to feet, how many feet are in a mile? Alexa, how many feet are in a mile?
1 mile is 5,280 feet.
Okay. So we have to multiply these to change it into feet because that would be equal to 1 mile, and this is unit analysis. The miles cancel, leaving us with feet. So I'm going to times 2.657, 2.657 times 5,280, and I get 14,028.96 feet. So that would be yes, the plane will have enough angle of ascent. Right? Because it only needs to get over 11,000 feet. And we're going 14,000 feet. A carpenter installs a brace to hold up a sagging gate so it is square. How long is the brace? Well, that would mean that this has to be a right angle for it to be square, and so we want to know how long this piece is, and that's the hypotenuse. And we have this angle here, and it's pointing to this angle. Is that angle adjacent, or is it opposite? Yeah, it's opposite. So which of our trigonometric ratios is opposite and hypotenuse? So we have I can stop there because that's opposite and hypotenuse. We're going to use the sine of that angle is going to be equal to the opposite, which is 3 feet, over the hypotenuse, which we're looking for. To figure that out, I would have to multiply each side by x and then divide by sine. So x is going to equal 3 divided by the sine of 33.847. I don't know if my calculator will do this because of that division. 3 divided by 3 divided by, it's not working. 3 divided by 33.847 sine. I'm getting not what I'm looking for. So I'm going to have to use a different calculator. 3 divided by the sine of 33.847 is equal to 6, because it's 4.5996. I'm just going to round it to 4.6 feet. And that is how long the brace will be. When you're ready, turn your page. Okay, we have some examples where they're asking what the angles are of A and B. So if I want to figure out A, that angle, I know that I have the adjacent side and I have the hypotenuse. And that is cosine. So toa. So the cosine is adjacent over hypotenuse. The cosine of A is equal to 1 over 4. Now to figure out what the angle is, I have to use the calculator, and so in my calculator I will use the inverse, which looks like I believe on your calculators that it looks like this with a little 1, and you may have to use a function to do that. So I'm gonna actually just pause the video and show you guys how to use these with the how to use the calculators to do these problems. And then after that, you will do these problems in your groups, and then you will be finished with your notes.